Welcome everyone. Today we are going to learn the chapter named as Mathematical Logic. The first chapter of paper 1, class 12. Weightage of this particular chapter is 8 marks. A very simple and scoring chapter. So let us start. First, we have to try to understand what is the proposition or the statement. So what is a proposition or a statement? A proposition or a statement is declaration which is either true or false. So any proposition or statement is a declarative sentence which is either true or false. Let's take some examples. 2 plus 2 is equal to 5 is a statement because it is a false declaration. 2 plus 2 is 4, but here they have given false declaration. It is a declarative and it is a false. Let us go for another example. Orange juice contain vitamin C is also a statement because here the sentence is a declarative and it is a true statement. Open the door is the next example. Open the door is not a statement. Why? First, it is not declarative. Second, you can't predict this as a true or false. So it is not a statement as it is not a declarative. Let us go for next. Next is examples of proposition. In that, let us go for the next example. It is raining. Is it a declarative? Yes, it is a declarative in a given situation. So it is a proposition. Beijing is the capital of China. Is it a declarative? Yes. We can answer this as true or false. So it is a declarative. So it is a statement in a logic. 1 plus 1 is equal to 1 plus 2 is equal to 3. Again, it is a declarative and it is a true. Let's take few sentences which are not proposition or they are not statement in a logic. Who is there is an interrogative word sentence and you can't answer this in true and false. Therefore, it is not a proposition. So for proposition, first you will check whether it is a declarative or not. Then you will check whether you can answer this in true or false or not. La 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 la. Meaningless interjection. Hence it is not a proposition. Just do it. Imperative or it is a command. Hence it is not a proposition because it is not declarative. Yeah, I sort of do know whatever. Again it is not a declarative. Hence it is not a statement in a logic. 1 plus 2. Since here they have not declared the result. So this is also not a declarative. Hence you can't answer this in true or false. Therefore, it is not a proposition. Now, we understood what is a statement or a proposition is. Now let us try to understand what are the different type of the statement we are having. There are two type of a statement. The first one is atomic or simple statement. So what is an atomic or a simple statement? A statement without any connective is a atomic or a simple statement. What is an atomic or simple statement? A statement which are without any connective. And the statement with some connective is known as a compound statement. The second type of the statement is a compound statement. The statement which are with some connective are known as the compound statement. So what are the connectives that we are having? Connectives like and, or, if then, either or, neither nor, so that, but, all these are the connective that we use to connect two different statements. So the statement with some connective is atomic statement. Sorry, the statement with some connective is compound statement, and the statement with some without any connective is known as the atomic statement. Now let us start with the first connective, that is a negation. Negation is a spatial connective. Negation is a spatial connective. It not going to connect two different atomic statement. It is going to modify a statement. The connective that we are using over here is negation. Is a operator. The connective that we are going to use over here is and. Sorry, it is not. The connective that we are going to use over here is not. And this is the sign to represent this connective. Transform a proposition into a logical negation. Let us take an example. If P, I have a brown here, then the negation of this is going to be, negation of P is going to be, I do not have brown hair. What we did here, we introduce a connective that is not. We are using a connective that is not. So this is a special type of connective which just modify the given statement. Now let us try to understand the truth table for not. So what is a truth table? It is all observation that we'll see by using all possibilities of the statement P. There are two possibilities for any statement. Either it is going to be true or it is going to be false. If it is true, then we are going to represent that with capital letter T, and if it is false, then we are going to represent that with a capital letter F. Right? Now let's see the truth table. If there is only one statement, that is P, then P can be true, P can be false. If P is true, then the negation of P. If P is true, then the negation of P is going to be false. And if P is false, the negation of P is going to be true. This observation is known as the truth table. So, What is the truth table for negation? If a statement is true, the negation of the statement is going to be false. And if the statement is false, then the negation of the statement is going to be true. Let us go for the next. The next compound statement that we are going to learn is conjunction. Conjunction is used when the connective is and. This is a symbol that we use to represent the conjunction. And we are going to read this symbol as and only. So it is a binary operator which connect to two different statement by using the word or by using the connective and. For example, if I take a P, atomic statement P, I will have salad for lunch. And there is another atomic statement Q which says that I will have steak for dinner. Then P and Q is an atomic statement, it is a compound statement, and here the conjunction we call this as a conjunction. So P and Q is I will have salad for lunch and I will have steak for dinner. This is what the P and Q is. So what is happening over here? The two different statements P and Q are connected by using a connective and. Then this compound statement is known as a conjunction. Now let us see the truth table for conjunction. So what is the truth table for conjunction? If you have a conjunction, then that is represented by and. This is a symbol for and. Now here you got the two different atomic statements. The number of proposition or the number of statement represents the number of rows of that we are going to use in a truth table. So how many rows are there? It is 2 raised to n. So what is the formula for getting the number of rows? Number of rows of your statement, yeah, all different combination of the two atomic statements is going to be 2 raised to 2. Formula is for 2 raised to n, where n represents the number of proposition. So it is 2 raised to 2, which is equal to 4. So there will be 4 rows, right? Now let us see. We got P, Q, and there are 4 different combinations. What are the 4 combinations? Both can be false. P is false, Q is true. P true, Q false, or both are true. So how many rows we are having? 1, 2, 3 and 4. 4 rows. Why 4 rows? Because there are two different atomic statements. So number of rows we are having over here is 4. How to write these 4 rows? Let me clear that also. You are going to write first 2 false, then next 2 false or true, then alternate false true, alternate false true. In your textbook you have in a reverse way. Instead of true, so in textbook you have something like first 2 true, then false false, and Q is alternate true false, right? This is you have in a textbook and you are going to follow the same. Over here we got false false, then true true, and alternate false true. Now what is the rule for getting and? If both the statements are true, then only it is true, otherwise false. It is very simple to remember what I said. If both P and Q are true, then only P and Q is true, otherwise false. Let me repeat. If both P and Q are true, then only true, otherwise false. Look here. False and false, false. False and true, false. True and false, false. True and true, true. If both are true, then only true, otherwise false. Hope you clear with the conjunction. Let me go for the second one. Actually, third one. It is disjunction. So what is a disjunction? Disjunction operator. Whenever you connect two different atomic statement by using the connective or, then it is a disjunction. How to represent that or? By using the letter V. This is a symbol for disjunction. How we do read this? It is or. We are going to read this as or, right? So whenever two atomic statements are connected by the operator or, then the compound statement is known as a disjunction. Let us take an example. We take one statement P. This is an atomic statement. All the atomic statements are represented by small letter. So one atomic statement is P, which defines my car has a bad engine. There is another atomic statement, that is Q, which says that my car has a bad carburetor. Now I want to connect these two statements by using the connective or. So what it is going to be? Either my car has a bad engine or my car has a bad carburetor. Over here we are using the connective or. So it is a disjunction operator. Right? Now if you use this X or a V that split the wood into two parts, and you can pick either of them or both of them. This is the meaning of or. Right? So you have either P or Q or both. My car has a bad engine, it is possibility, or the car has a bad carburetor, this is also a possibility, or there is a possibilities of both. Right? That is what the meaning of or is. Let us go for the next. The truth table for or. If P or Q means that P is true or Q is true or both are true, right? P or Q is going to be true if both are false. P or Q is true if either of them is true or it is false. So this operator is called inclusive or, because it includes the possibility that both P and Q are true, and together are also universal. We are going to take how many different statements are there? Two statements are there. So how many number of rows are going to be there? Do you recollect the formula for number of rows? The number of rows is equal to 2 raised to n, which is equal to how many atomic statements we are using over here? 2. So it is 2 raised to 2, which is equal to 4. How to write that four different combination? For P, first two true, next two false. As per your textbook, over here I am using first two false, then next two true. And for Q, alternate false to false to false to. Now what the table says? The table says that P or Q is false only when both of them are false. Otherwise it is true. P and Q is false only when both are false. Otherwise it is true. In other way, if either of them is true or both of them is true, then it is true, otherwise false. So P and Q both are P or Q is false only when both P Q are false. Otherwise it is going to be true. That is what and how we remember the table of disjunction. So we did the three compound statement. Let me revise the all three compound statements. First was the negation, second was the disjunction, and second was the conjunction, and third one is a disjunction. Over here, remembering the table is very important. So how to remember the table? For negation, true ka negation is false and false ka negation is true. For conjunction, how to remember the conjunction? If both are true, then only true, otherwise false. If both are true, then only true, otherwise false. And how to remember disjunction? If both are false, then only P or Q is false, otherwise it is true. If both are false, then only P or Q is false, otherwise it is a true.